Well, first of all, thank you for having me here. I'm Jorge. I'm a security consultant from Argentina, and I'll be here presenting a kind of twisted attack for Internet Explorer. You will see why it's twisted later on. Here's a summary of what we will be discussing. First, I'll just introduce the attack results, what an attacker can do by performing the attack described herein. Then we'll move to a brief description of some well-documented features of Internet Explorer, some mechanisms that are known to exist and were designed in such a way that a programmer, a developer, can build applications based upon those rules. Then we will discuss some other features that are not so well documented, but they can be perhaps abused in such a way that involves a minor security risk, each of those features in and of itself. But then, in the next section, we will see how we can strung all of these features together to build an attack vector. Then we will go in deeper detail about the overall impact that the attack vector has. We'll show a demo, and then we will see the possible workarounds for the attack vectors described. Well, as a successful compromise of Windows Explorer user will allow an attacker to have a blind but full access to every single file in the victim's local drive. By blind, I mean the attacker cannot know beforehand the exact location of the files because it has not the ability to browse the hard drive. But given the way Internet Explorer and Windows Explorer itself handles its internal files and how they handle the user activity, you can access most of the sensitive files through these mechanisms. Those files include binary files and text files. You can access also cross-domain information such as cookies for the website you're visiting and all of the history files. Backup files in network administration environments are really common. Files that the user has been working with recently, personal pictures, and other files depending what is the function of the machine that is browsing, that is being compromised. I mean, if this machine is an IIS server, you can try to access files inside the web root folder, or configuration files depending on which applications has the computer installed. Well, every web browser has its own design patterns that have been decided at design time by the developers. Internet Explorer has its design patterns, and some of these patterns are known to be there and are well documented, so developers can build applications based upon those rules. We will be reviewing here the security sum scheme, the sum elevation rules for web applications, and the Mime type detection. Those are features that are related to the attack we will be exposing here. The security zone scheme allows users or administrators to classify websites to belonging to one subset or another, and each of those subsets has different privileges regarding to which Internet Explorer objects that website can access. Yep. The question is for which version of Internet Explorer the attacks does work for every Internet Explorer version. All of the Internet Explorer versions share all of these features that we will be discussing here. You're welcome. Each of these subsets has a different set of privileges depending on how trustable is the web application. The security zones are known are the restricted site zone, the internet zone, the trusted sites zone, the local intranet, and the local machine in an ascending order of privileges. Then there is a kind of behavior that a web application or a web page can present that is known as zone elevation. That is when a given application that belongs to a given zone tries to load or to reference content that is actually located in a higher privileged zone. This behavior is only allowed for the restricted site zones. I mean, a site located at the restricted site zones could reference eventually a resource located in the internet zone, which is a bad idea because a couple of years ago, the first attack vector that in this line of attacks abused also of this feature. But, for example, you cannot elevate privileges from a site located in the internet to a local machine or to trusted sites. That reference, that kind of elevation is not allowed. Then there is the MIME type detection that comes to play when you're accessing, using Internet Explorer, you're accessing a web resource. The browser has to decide how will be treated that resource. I mean, if it will be rendered as HTML, if it will load an ActiveX component to work with it, and to determine which action it will take, it uses an algorithm that is based on one hand the content type supplied by the server that is serving the content, and on the other hand, the decision is based upon a function that Internet Explorer has internally that is called find MIME from data, that basically scans a small buffer, 255 bytes of the first 255 bytes of the object that was retrieved, and then it takes the decision that how it will be treated. If the server supplied MIME type is unknown for the browser, the browser will treat the object that was requested according to the result from the find MIME from data function. I mean, if the file extension is unknown for the browser and this function determines that the content that is being trying to render is HTML, the browser will treat that object as such. In the case that the MIME type is either or known or ambiguous, the buffer will be scanned anyway because the browser will not trust directly to the server-supplied content type. And if there is a coincidence between the content type that the server supplied and the content type the find MIME from data function has found, the browser will take action according to that content type. But when there is no coincidence and the server supplied MIME type is known, I mean, for example, if the object that the server is serving is an HTML resource, is a content type text HTML, and the find MIME from data function cannot reliably detect that this is actually HTML content, it will take an action based on another thing. If there is no conflict between the base data type of the resource, where conflict is if the file is detected to be a text or binary file, the server provided Mime type will be used in that case. So if there is a conflict, if the server supplied content doesn't match the base content type, I mean, for example, for an HTML file, the find Mime from data function determines this file to be a binary file, there will be a mismatch, so the algorithm will keep trying to determine the file type, the actual file type, by trying the extension of the file. And if there is no coincidence after matching the extension with the extensions that Internet Explorer has set in the Windows registry, the content type will be defaulted to text. I know it is a bit long, but the point is that one of the key steps is perhaps the one in which the server supplies a content type, and the find Mime from data function is not able to determine the real content type. So when there is no conflict, the browser will be forced in a way to render the content as it is the content type supplied by the server itself. Well, now let's dig a bit into some other features that Internet Explorer has that have to do with the attack itself. But those are not so well documented. Some of them are known, are even documented in a good book that is the Browser Security Handbook that Michael Zalewski wrote a long time ago. Well, let's start with the first of these features. Internet Explorer has a way to track the user activity and to keep their sessions and their history files that is based on storing that information in special files and folders located under the user profile folder. As some kind of innocuous security measure, those files are randomly named. They don't follow at least an easy to understand pattern, the names and the names of the files and the folders that Internet Explorer internally uses. And although those names and those names of the files and those folder names are random, there is a map. Internet Explorer builds some kind of map in a file called index.dat. And actually there are more than one. There are multiple index.dat files that are intended to track different things. Some are for the cookies, some are for the user navigation, and so on. There are a lot. But these files, besides storing the information that we have mentioned, this information is not the only thing that they store. They store also another type of information. I think that it is for internal usage of Internet Explorer, but the thing is that the sensitive information is the only thing that in the file that it seems to be stored in plain text. So I think that's not a really good idea, and that's a key to access those key files, as we'll see later on. Well, another feature, in fact, this is a kind of group of features. Internet Explorer behaves much like Windows Explorer in many aspects. Both of them share the treated layout engine, that is the one in charge of rendering the objects once presented in the main window. Both of them also support UNC paths for accessing SMB resources. This way, Internet Explorer lets you perform some kind of tricks that Windows Explorer also does, as we can see here, for example. I don't know if it can be read what is in the title. If not, I'll zoom it. For example, when using Windows Explorer for accessing the history folder, what is shown in there is not the actual content, on the real content of the folder, but some kind of schedule so the user can try to browse it in that way. But if you try to access the same folder by referring to your own computer using the UNC notation and accessing the SMB shared administrative resources, you will see what is actually in there. There is a file and a folder, as can be seen there. As can be seen here, well, the full name is not shown here, but Internet Explorer allows accessing it the same way. You can access files in that folder also. Another feature that Internet Explorer shares with Windows Explorer is that it can trigger SMB requests to any website on the whole Internet. So if you include a tag like this one in a web page, the user visiting that page will automatically trigger an SMB request towards that website. And as part of the challenge response negotiation corresponding to that SMB request, the Windows Explorer will automatically try first to obtain this resource anonymously, and after it fails, it will automatically also try to authenticate with the current user credentials. So the remote server can learn from that request the Windows Explorer username, the domain name, the computer name, and it will have also the results of the challenge response negotiation that will have place. This also involves another security risk that is not used in this attack, but an attacker could try to crack the challenge response negotiation and try to access the victim's computer directly by SMB. Well, another of the Internet Explorer features has to do with how to classify a website or a URL into as if it belongs to a given zone. One of the rules that can be read in the SDN documentation is that a UNC address will be treated as belonging to the Internet security zone when the path written in that UNC address contains the IP address of the target machine. And when the name, if there is no an IP address but a name, this name, if it doesn't have any dots, will be treated as belonging to the local Internet zone. What makes sense because it is the only way that a name cannot have dots is because it is a local Internet name. And if it has dots in the middle, it will be treated as belonging to the Internet zone, unless, of course, added to the restricted site zone or the trusted sites explicitly. But when referring to your own computer, there is a kind of problem, because referring to / your computer name will make reference to the local Internet in spite of this being actually your own computer. It will be treated as belonging to the local Internet zone. And even more, when referring to it through its IP address, through the loopback IP address also, will be treated as belonging to the internet zone. This feature of Internet Explorer fits the rules of URL classification that Internet Explorer has documented, and shouldn't be a problem in and of itself, but it's one of the key steps in the attack that we'll be showing here. We have a lot of conference calls with the Microsoft Security Response Center, and they are kind of their words are that they are kind of stuck in here because this feature cannot be easily fixed, to say something, because they cannot assign those addresses to their default corresponding zones without having impact on already existing applications. Well, and let's see why could that be a problem. That could be a problem because according to the security zone scheme, a page that is located in a given zone cannot neither reference or redirect its navigation to a more privileged zone, because it will be a zone elevation issue and it is not allowed. But if considering this dialogue between a computer and a random server in the internet, if the server redirects the navigation towards a file that is located in the own victim's computer, the redirection will be successful because it doesn't break any rules. It agrees with the guidelines of the Internet Explorer security zone scheme. So the redirection will occur. There is also another way to bypass or to render useless, in this case, the security zone restrictions. That is by basically using another protocol to access the resource, the remote resource. For example, if you're using HTTP for accessing a resource that is located in a web server that is explicitly added to a restricted site, if you can access the same server by using HTTPS or SMB, the same resource will be treated as belonging to internet. So the restrictions applied explicitly will not have effect. Here you can see something that is hard-coded some way in Windows behavior. The cookies folder here is treated always as a restricted site, because the content stored in there is considered to be some way dangerous. But if you access the same file by using the UNC notation, the file is located in a zone that is internet, and the restrictions does not apply anymore. Well, now let's see how could manage an attacker to put some way HTML or scripting code in clients' hard drives. It can be done currently, as in every web browser, through the navigation history files, through cookies, or in the case of Internet Explorer, also through the mapping files that are the index.dat files we have discussed before. This is a feature that is common to every web browser, and that's okay, but the problem here is not in the feature by itself, but in the way it is implemented, because on the one hand, those contents sent from the internet are saved on those tracking files with little or no sanitization at all. So if you send something that that can be some way interpreted as code, it will be stored as it is. And also, Internet Explorer, as most of the web browsers, allows rendering files that are not pure HTML, but they have HTML parts as HTML files, and they will simply ignore the parts that cannot be rendered. For example, if you request a page in a server and that server sets a cookie containing HTML code, the cookie content will contain actually that HTML code. Well, another feature that is used in this attack vector is abusing of the way Internet Explorer treats a given file based on the MIME type detection we have discussed before. As we saw, the decision of how to treat a given file is based mainly upon the server supplied MIME type and how this and the result of the find MIME from data function after scanning a small chunk from the file that was tried to obtain. But there are some problems in this implementation because, as we discussed at first, the server provided MIME type will be forced when the following conditions are true: when there's no positive match obtained from the find MIME from data scan, and the server provided MIME type is known, and there is no conflict. So the file is not entirely different from the one the server is suggesting. And there is also another problem that has been proved, that Internet Explorer doesn't behave consistently in the same way when accessing a same resource by different means. For example, when accessing a resource by direct navigation, Internet Explorer can render that resource in a given way. But if accessing the same resource through an if reference or through a scripting or through a redirection, the resource can be treated as if it was of another type. That has been also a key to carry out this attack vector. For example, in the first advisory we have published in this line of attacks, when a website contains an object HTML object referencing a resource that can be treated as HTML, the resource is treated as such. But the point here is when you try to access a resource, to treat a resource that is not HTML and that Internet Explorer will find not to be HTML through an object directly, Internet Explorer will complain and will not allow rendering that object. But if you access that object through a redirection, first referring to a valid HTML object and then referring to the object that is not HTML, Internet Explorer would actually render that object as HTML. That was the key to perform this first attack. Well, so far we have been just exposing some small features that Internet Explorer has. Perhaps it's not so obvious the connection between them, and what is indeed obvious is that some of them, or most of them, implies perhaps small security risk. I mean, for example, storing sensitive information inside index.dat files as text, as raw text, perhaps it's not a big deal because who could access those files? Or perhaps the classification for the URL, depending on if it is an IP address or if it is a name, when referring to your local machine, perhaps it's not a big deal while analyzed on its own. But let's see how can we combine all of those features to carry out an attack. We'll discuss two scenarios. The first one will have less steps and will be intended to cover a scenario in a local intranet where users have shared folders to exchanging documents, music, and so on. And the second will be more general, will cover the common internet user directly connected to internet. Well, the first scenario here has this series of steps. The attacker have to manage to put HTML files in the victim's shared folders in a network, in a local internet environment. This is quite common to find shared folders with right permissions. So someone in the network could just put an HTML file in there. Then this malicious employee in the company could send the user a link so the user clicks on that link, and then a redirection occurs towards that file. In that way, the attacker could put a malicious HTML file in the shared resource, and after clicking on the link the attacker sent to the victim, the victim gets redirected to the resource that the attacker uploaded to the victim's computer. So if this occurs, the attacker will have HTML code and script code running in the context of the victim's local machine, but with the privileges of internet, as we saw that it is the classification. This is actually indeed the victim's computer, but the privileges of the code running there will be as if it was a site belonging to the internet zone. Well, the most general approach is a bit more complicated to be carried out, but it is easily understandable after seeing all of the things we have been discussing so far. Basically, an attacker just should entice a potential victim to click a link to a malicious website. This website has to contain an image tag with a UNC path to the malicious server, as we saw before. This way, the attacker could manage to obtain the victim's actual username. That username will be needed to carry out the attack later on. In the meantime, this malicious web page the user is visiting will write in the victim's computer tracking files malicious HTML code. Then the server will be running scripts based on the information it obtained through SMB, will be running scripts so to build the right paths to the internal tracking files that, as we saw, are located inside the user's profile. That's why we needed the username. So these files the server is building will be referenced together after a redirection. At this point, the trick here is to force some way when redirecting the navigation to these files, the server wrote in, the trick is to force Internet Explorer to render, to treat those files as if it was HTML code. This is something that has been done many times already, and given the nature of the feature itself, given that it is not actually a bug but a feature, they cannot simply remove it. In fact, what Microsoft is doing so far is just preventing our proof of concepts from working, but every time they did it, we managed to find another way to do it again. So this has a lot to do with the complexity of the MIME tab detection. And well, if an attacker manages to perform that, will have the same impact as the previous scenario, that is HTML and scripting code running in the context of the victim's local machine, but with internet zone privileges. So, as a result of this attack, in the process, an attacker is able to store HTML and scripting code of her choice in the victim's computer. And by the redirection mechanisms, is forcing the victim's browser to load and render this HTML code. And as we said, this code is actually running in the internet zone, but is also running in the victim's local computer. So it has at least enough privileges to access every single file in the same origin. It doesn't violate the same origin policy. It doesn't violate the security zone scheme, the zone elevation. It's all right. It's according to the rules. So it can access a lot of interesting files, as we can see. We will see this in a demonstration right now. And well, before anything, this process of forcing Internet Explorer to treat a file as HTML has been done in 3 advisories so far. The last one is being published today, and it will be available. I think it should be available right now in the Core Security website. And the only difference between each of these vectors is the way in which Internet Explorer was tricked into rendering those files as HTML. And also, perhaps the difference was which files were used in each of those attack vectors. In the first one, I managed to use the cookies for this purpose. And in the latest two, the file I used is the index.dat that is used for navigation tracking. And as this is the only thing Microsoft is fixing, Microsoft isn't fixing it. It's just twisting it a little bit so this proof of concept doesn't work, because they cannot fix something that is not a bug, it's a feature. That's a problem. And that's the reason why we are still doing it over and over again. Well, let's see if it works. Let's see if all I told you it's actually true. For this demo, what I will do here, I have built a module for BIF. BIF is a cross-site scripting exploitation framework. Most of you should have heard of it. What I will do here is just open Internet Explorer and do what an attacker will do in this case. Point a victim to a malicious website. If you have used BIF before, you will recognize this URL as it is the default connection page for Beef. So once the user is visiting that page, it will automatically be logged and accessible in the Beef console. From here, an attacker using Beef always has been able to send custom JavaScript code, and even there are some exploits for browsers available right now. Well, this is the model I have developed. By pressing this button, what should happen here is the following. The web server will send the client code for appending a dynamic SMB referenced image. So the server should learn this information from the victim. Okay, I have to select it first, and let's go again. After this, the server is automatically building the files that should be targeted right now. Here, if you see, the URL has changed because a redirection has occurred to another web page, which is indeed loading the local index.dat file from the victim. As I wrote a specific code in a specific HTML and scripting code in those files, I have enabled some functions in that file to access the client's computer. For example, here is the folder for uploads, and let's see if I can get the boot.ini file from the C hard drive. If you take a look to it's difficult to look at both at the same time, but if you take a look at this page won't change. It will keep the same because it's just submitting a form and receiving a 206 no content response, so it will not do anything. It will not change. This way we can get every file we want, but let's get some interesting files. For example, documents and settings, Jorge, because this is my username, cookies, index.dat. Then I get this file. It is here. I built a script to parse this file. Let me go there. Let's parse this file. You can read the screen? Right. Well, let's put it all in a text file. And then we can try to access directly each of these files. Some of these files perhaps are expired, but most of them should be there. If I try, for example, this one, let's see what happens. It was there actually. So the cookie is this one, and as you can see, we managed to get not the cookies for random domains, but the cookies for all of the domains the user has set. This way we can also access another interesting files. For example, in local settings, history, IA5 index that again. This is another of the tracking files, and it is indeed the one I'm using with HTML code inside and loading that file in the victims. If you click here, you will see here is loaded the file, but I just hidden it for statics. Then we can parse that file also. Local settings. Let's put it in history. TXT. Let's open it and see what can we get from that computer. Let's change it a bit so I can access it directly. And we can, for example, try to get this file, which is actually in the desktop, but it is in this file because I have accessed it some time ago. So it got written in the tracking file. Then in the uploads, it should be this file. That is, in fact, the white paper I wrote about this with more detail on all of the things we have discussed so far. Well, this way you can access every file the user has been working with since the last time he cleaned his browsing history. I think that's not so common. At least I do not do that quite often. It also includes pictures, and even if you get access to the thumb.db files in the My Pictures folder, you can track all of the files in the current folder and even access the thumbnails that are stored in those files. For example, this is one of my pictures in my folder with some friends of mine in my hometown. Well, when we started publishing this line of attacks, we had not the full knowledge of what was really going on, because we, as Internet Explorer is a closed source product, it's not easy to see what is happening behind scenes. So we were learning more and more about this problem as the time was passing. So in the CVE, in the first CVE that was published, it was treated as if it was a zone elevation issue, and as we saw, it is not. There is no zone elevation. We're not elevating anything. It's just intended functionality abused in a way. And even the CVE for one of the last advisories we published tags it as a cross-domain information disclosure vulnerability, which is not. It is also a cross-domain information vulnerability because you can actually access information of other domains, but you can access actually all of the information in the local drive. So it's more than that, I think. And as we saw along the presentation, both of the problems are the same. So let's discuss some workarounds, because by now Internet Explorer is actually vulnerable to this attack. There is no fix yet. So let's see what we can do about it. One of the things that can be done is locking down the Internet Explorer network protocol. That is a setting that you have to set in the registry or in the internet configuration for your computer from the control panel. You should basically disable the access to UNC resources and file using SMB resources on Internet Explorer. If you're a normal user, perhaps it will not affect you that much, but that's one of the alibis Microsoft has to not to remove that. Another countermeasure that can be taken is to set the security level for the internet zone and for the internet zone also to high, which will be really annoying because you will have to confirm every JavaScript that executes in the internet. I think no one wants to do that. Also, another option is just to disable the active scripting for both of these zones, internet and local internet, which is, I know it's ridiculous, but it is a countermeasure anyway. Then another solution is to run Internet Explorer only in protected mode, but that will just work in modern operating systems such as Windows 7 or Windows Vista. And I found protected mode also to be really annoying. I don't know you, but I don't use it in that way. Well, another workaround that can be suggested is just to use a different web browser when browsing somewhere that you don't know what can you find. Well, that's it. Any questions?
Has Microsoft implemented their workaround for this particular issue? Or I know you mentioned in previous issues they implemented workarounds, but did they implement the workaround for this one?
For
the latest?
Yeah. The question is if there are specific workarounds for this particular issue I'm exposing here, the latest one. As we said, all of the issues are actually the same. So the mitigation factors are the same. The countermeasures are all the same for the first advisory, for the second one, for the third one, and will be for the fourth one. You will see one, I promise.
So right now, the attack you just did will work on a fully patched IE.
Yeah.
Have you checked Outlook?
Sorry?
Have you checked Outlook?
If I have a look at Outlook?
Yeah.
You mean if Outlook perhaps is vulnerable to this kind of features also?
Yeah.
Well, in fact, that's something funny. I got really upset at first because when I first found this vulnerability to exist, the way I was forcing Internet Explorer to treat a cookie as an HTML file and render it was by using a protocol handler that is mHTML for Mime HTML, right? Well, that DLL is actually part of Outlook Express. So they blamed Outlook Express as being the responsible for this feature, for this problem. But Outlook Express is always installed in every Windows installation. You cannot disable it, and even so, if you choose to not to install Outlook Express in the installation process of Windows, the DLL will be there anyways, will be installed also. So I think they tried to minimize the impact of the new when the vulnerability went out, but it was the same because we then found another way to do the same thing without using any DLL.
Two questions.
Yep.
First one is, can you recommend or are there any good third-party Mime handlers? And the other question is, when you mention running IE in protected mode, are you talking about turning on data execution prevention, or what is it you're talking about specifically?
No, the protected mode is actually a component of the operating system that is indicated in Internet Explorer when you're browsing internet with Internet Explorer in either Windows 7 or Windows Vista. You will see in the information status bar if this mode is activated or not. This mode is based upon some other components of the operating system as user account control and another kind of features, but you have to be using one of those operating systems to enable it.
And the other question was Mime handlers. Are there any
if-
good third-party or is there a good way to implement the built-in Mime handling so that it handles content types properly and fully?
You mean in other browsers?
In other browsers or even in this one, it seems like, this is terrible.
Yeah. The point is, the problem arises in the way it is implemented more than in the way it is thought. In the white paper that will be available in the Black Hat website and also in Core Security website, I have made also an analysis of a comparison with another web browsers and why this kind of attack cannot occur in other browsers. For example, just to name one that caught my attention, when, for example, Firefox, when dealing with SMB resources, it has a kind of privilege separation regarding to in which folder is the file that is being rendered. For example, if you have a folder A and then a folder B, a file inside that folder B cannot access a file in the folder A because that will violate some sort of same origin policy. But this is not the case in Internet Explorer. As we saw, the index.file is inside the user profile folder, but I am accessing here every file in the local drive. So
So the Mime handling is done by IE and not by the operating system.
it's the MIME handling. It's perhaps another of the problems because it's not determining so well the content type that has to be used. But for example, Firefox doesn't support UNC addresses also, so you can access a resource by SMB using the file :/ protocol, but you cannot use UNC because that's a Microsoft thing. That's a Windows Explorer thing and also an Internet Explorer thing. I don't know if I've answered your question. Okay.
How is your script actually setting the files on the logs? What are you doing?
Well, would you like to take a look at it? I think we have time. I'm not quite sure, but well, that's something that I forgot to mention, but it was written here. Another feature that Internet Explorer has, but I think it is good, not only for my demonstration purposes, but it is something really, really good. The dump document 3.0 object has the ability to read not only text files, but either binary files, because you can load contents from a container into a variable, and you can set those contents to be binary. Let's see if I have the source code here. It's actually a VB script file because it has some, as I said, the only thing that can access UNC resources is Microsoft. Firefox will not do this because it makes no sense in Firefox. You cannot use / a computer IP or name. And by creating this object, you can create a binary element in this XML document object. Then you encode this content in base64 because in other way you could not send it to a remote place, and that is what we're doing here. And then we're just bypassing the same origin policy as everyone does, as VIF does, for example, that is creating a dynamic form and filling that form, setting an action, the action for that form to another place, and then sending that form. Something else? Well, that's it. So, thank you very much.